press the bell icon on the YouTube app and never miss another update.
Welcome to lecture number 3 of chemical bonding. In the last class, we had discussed regarding the concepts of electrovalency, factors affecting the formation of ionic bond, followed by different properties of ionic compounds. In this class, we are going to discuss regarding the concepts of lattice energy. What is meant by the concept of lattice energy? It is represented by U. What is meant by this word lattice energy means it is the amount of energy released. It is the amount of energy released when one mole of ionic compound is formed by the combination of a gaseous cation and gaseous anion. Okay, it is the amount of energy released when 1 mole of ionic compound is formed by the combination of a gaseous cation and gaseous anion. It is called a lattice energy. Okay, then how do we calculate this lattice energy? Is there any direct methods for that to calculate the lattice energy? No, there is no direct methods are there for the calculation of a lattice energy. Instead, we have one indirect method. By using that, we are going to calculate the lattice energy. That indirect method is nothing but a Born-Haber cycle. That is nothing but Born-Haber cycle. Okay, by using this Born-Haber cycle, we are going to determine the lattice energy of a ionic compound. Now, what is the definition of lattice energy? It is the amount of energy released. It is the amount of energy released. ಯಾವಾಗ ರಿಲೀಸ್ ಆಗ್ತದೆ energy? It is the amount of energy released when 1 mole of ionic compound, 1 mole of ionic compound is formed by the combination of gaseous cation and anion. The energy released when 1 mole of ionic compound is formed from its gaseous cation and anion is called a lattice energy, and there were no specific methods for the calculation of lattice energy. One indirect method is there for its calculation, that is according to a Born-Haber cycle. Okay, this Born-Haber cycle, in order to study this Born-Haber cycle, we need to know about some more different energy formats. That is in order to learn this concept, we need to go through one important concept, that is enthalpy of formation. Enthalpy of formation, we can represent it like this, delta HF, where this delta H represents the enthalpy or heat of formation or enthalpy of formation. Now, what is meant by this word enthalpy of formation? This concept is similar to that of this lattice energy concept, but it is not exactly equal. Enthalpy of formation is nothing but when again 1 mole of ionic compound is formed. When 1 mole of ionic compound is formed from their elements in their pure and stable state. Here sodium is not existed in a Na plus state. In Na plus state, sodium is in a gaseous state, but the pure form of sodium in its elemental state, it exists in a solid state, where a Cl2 molecule also it is exists in a gaseous state in its pure state. When these two pure state elements combine together to form a 1 mole of ionic compound, and that energy released during this reaction is called enthalpy of formation. The name itself indicates that during the formation of 1 mole of ionic compound, by the combination of elements in their pure and stable state. The energy released is nothing but energy of formation. That is, it is the amount of energy released when one mole of ionic compound is formed from elements in their pure and stable state. This is very much important. This is the difference between the definition of a lattice energy and enthalpy of a formation. Okay, where in case of a lattice energy, we are going to have a positively charged cation and negatively charged ion in their gaseous state. That is the energy released during the combination of cations and anions in their gaseous state. But here it is the amount of energy released when the combination of elements in their pure and stable state. Okay, this is the first. Now we are going to know about the Born-Haber cycle. Born-Haber cycle. Born-Haber cycle for NaCl molecule or NaCl compound. It is okay. Here, what is our motto? Our motto is to find out, our aim is to find out the lattice energy of this compound. Okay, lattice energy, this is our required equation. Okay, how can we calculate this? What is our enthalpy of formation? That equation is nothing but sodium and chlorine here both are in their free state. They are also results in the formation of ionic bond. But from this equation, from this enthalpy of formation, we are going to extract this equation. We are going to prepare this equation. That means this is a lattice energy equation. Here, in order to calculate the lattice energy, we have to prepare this equation by using the equation of enthalpy of formation. Okay, now in order to find out this lattice energy, we are going to discuss the concept of a Born-Haber cycle. Here, sodium atom is in a solid state. What we are going to do now? First, we have to convert this sodium into gaseous state. How do we convert solid into gaseous state? And what is that process is called? The process of conversion of a solid and directly into a gaseous state is called sublimation. Sublimation anta kariತೀವಿ. The process in which solid is converted into gaseous state. Okay, and the enthalpy required during that reaction is called delta H sublimation. Whether the amount of energy required to this reaction or amount of energy is liberated by this reaction. Here, in case of this reaction, some amount of energy is required in order to convert this solid into gaseous state atom. Here, some amount of energy is required, means for this reaction there is a requirement of energy takes place. That means it is an endothermic reaction. Then enthalpy of this reaction is positive. Enthalpy of sublimation is positive. Followed by, now we had prepared the gaseous sodium cation, but what we want sodium cation. Okay, in order to convert this gaseous sodium cation in sodium atom into sodium ion, what we are going to do? We just remove one electron from the outermost shell of sodium atom. In order to remove that electron, which is the amount of energy, which is the energy required to remove that electron? that energy required for the removal of electron from the valence shell of gaseous atom, that is ionization energy. ಒಂದು gaseous atom ಇಂದ electron remove ಮಾಡಬೇಕಾದಾಗ we have to apply some amount of energy. That energy is nothing but ionization energy, where this sodium atom is converted into sodium ion after the loss of one electron, and energy required to lose that electron is nothing but ionization energy. And delta H ionization energy is also positive. Why it is positive? Here amount of energy is not released, instead amount of energy is required by the system, that is why delta H is positive here. After providing some amount of energy only, sodium it loses its one electron and it converted into gaseous cation. Is it clear? Here our aim is to convert the sodium atom which is present in its solid state or in a pure state to convert that atom into ionic state or cationic state into a gaseous state. Okay, in order to convert that atom from the solid state to gaseous cation, we are going to these processes. First one, it is a process of conversion into solid to gaseous, that is called sublimation. And in this process amount of heat is required by the system, that means this is an endothermic reaction where the enthalpy of sublimation is a positive, followed by after this sublimation we are going to get the sodium atom in its gaseous state. From this gaseous state a removal of electrons takes place, and energy required to remove that electron is nothing but ionization energy. After providing that ionization energy, this is sodium gaseous atom which is converted into sodium cation. Sodium cation agi convert aitu. Now one process is over. Next we will come to Cl2. Okay, here Cl2 already existed in a gaseous state. No need of sublimating this Cl2 because already it is existed in a gaseous state. Now what is our aim? Is just convert this Cl atom, or this is in a molecular state. We have to convert this Cl2 molecule into a Cl atom followed by Cl ion. Okay, first we have to convert this into, this is like this, ಈ ಥರ ಫಾರ್ಮಲ್ ಇದೆ, ಮಾಲಿಕ್ಯುಲರ್ ಫಾರ್ಮಲ್ ಇದೆ. ಇದನ್ನು ನಾವೇನು ಮಾಡಬೇಕು, ಈ ಬಾಂಡನ್ನು ಡಿಸೋಸಿಯೇಟ್ ಮಾಡಬೇಕು. ವಿ ಹ್ಯಾವ್ ಟು ಡಿಸೋಸಿಯೇಟ್ ದಿಸ್ ಬಾಂಡ್ ಟು ಕನ್ವರ್ಟ್ ದಟ್ ಮಾಲಿಕ್ಯೂಲ್ ಇಂಟು chloride atom. Okay, so the energy required for that is a dissociation energy, and this is called enthalpy of enthalpy Na plus half Cl2, we are going to get NaCl. It is in a gaseous state. ಇದಕ್ಕೆ ಏನಂತ ಕರಿತೀವಿ ನಾವು, ಡಿಸೋಸಿಯೇಷನ್ ಆಫ್ ಬಾಂಡ್ ಅಂತ ಕರಿತೀವಲ್ವಾ, ಡಿಸೋಸಿಯೇಷನ್. ಓಕೆ, ಹಿಯರ್ it is converted into gaseous cation, but here we have taken half moles of Cl here. From half moles to 1 mole now convert ಮಾಡಿದ್ದೇವೆ. That is why this dissociation energy is divided by 2. And in order to convert this, or in order to undergo dissociation, we have to apply the amount of energy. That means this reaction is also what? This reaction is also endothermic in nature. This is also positive in nature. Enthalpy of reaction is positive here. Okay, now we had converted this into a gaseous anion or gaseous chloride atom, followed by this chloride atom is converted into Cl minus. How do we convert this atom into Cl minus ion? We have to provide one electron to this Cl atom. If we provide one electron into this atom, what happens? After the accepting the electrons, it will become Cl minus ಆಗ್ತದೆ. And the enthalpy change when an electron is added into this gaseous atom, that energy is nothing but, or that change in enthalpy is nothing but electron gain enthalpy. That is the, I repeat, the enthalpy change when one electron is added into the gaseous atom or outermost shell of a gaseous atom. Okay, that enthalpy change is nothing but electron gain enthalpy. Electron gain enthalpy. In short form, I write it like this: electron gain enthalpy. Here, what is the nature of heat here? Whether the amount of energy is released or the amount of energy is required by the system. Okay, while the addition of electrons, some amount of energy is released by the system. That means this reaction is exothermic in nature. That is why electron gain enthalpy is negative in nature. During the addition of electrons, some amount of energy is released. During the addition of this electron, amount of energy is released. That means this reaction is exothermic in nature. That is why finally we convert this chlorine molecule into gaseous chloride ion. Now we had with the sodium cation and chloride anion. Ultimately these two get combined with each other to form 1 mole of what? 1 mole of ionic compound. 1 mole of ionic compound. Here, this is called lattice energy. How the? This is called lattice energy. This is called lattice energy. Why this is called lattice energy? Just remember the definition of lattice energy, where this 1 mole of ionic bond is formed by the combination of what? 2 gaseous atoms. Okay, 1 mole of ionic compound is formed by the combination of 2 gaseous atoms. This is called lattice energy. If the same 1 mole of ionic compound is formed by the combination of elements in their pure state, ಆದರೆ ಅದೇನಾಗಿರ್ತದೆ? Enthalpy of formation ಆಗಿರ್ತದೆ. delta HF it is. Means this equation represents the enthalpy of formation, where this equation represents the lattice energy. Okay, now here the doubt arises: how do we calculate the lattice energy by using these equations or by using all these energies? Okay, in order to calculate the lattice energy of this molecule by using Born-Haber cycle, one more rule has introduced, or one more law has introduced. That law is called Hess law. Hess law. According to this law, we are going to find out, or we are going to determine the lattice energy of this ionic compound or any other ionic compound. Okay, then what does it says? Hess law. According to this law, the amount of energy released or amount of energy liberated, in a single step, is equal to sum of the energies of multiple step. ಹೀಗಂದ್ರೆ ಏನು? The amount of energy liberated in a single step is equal to sum of the energies of the multiple step. Here, which is the single step here? The enthalpy of formation is the single step here. According to the Hess law, the amount of energy liberated during the process of enthalpy of formation is exactly equal to all these energies, sum of all these energies. When we sum up all these energies, that means enthalpy of sublimation, ionization energy, dissociation energy, followed by electron gain enthalpy, all this sum of those energies, which is equal to the energy of enthalpy of formation. That is according to the Hess law. What it says? The amount of energy liberated in a single step is equal to sum of energies of the multiple step. ಈ ಎನರ್ಜಿಗೆ ಆರ್ ಎಂಥಾಲ್ಪಿ ಆಫ್ ಫಾರ್ಮೇಷನ್ಗೆ ಈ ಎಲ್ಲ ಎನರ್ಜಿಗಳ ಸಮ್ ಅಪ್ ಈಕ್ವಲ್ ಆಗಿರುತ್ತೆ ಅಂತ ಹೆಸ್ ಲಾ ಹೇಳ್ತದೆ. ದೆನ್ ಹೌ ಡು ವಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ದಿಸ್ energy or lattice energy of this reaction, especially this reaction? First, enthalpy, total enthalpy of the system is equal to, first which energy is this? Sublimation, delta H, sublimation, it is delta H sublimation plus delta H ionization energy. Second one, it is delta H ionization energy followed by delta H dissociation energy. Third one, it is delta H dissociation energy, but this dissociation energy is divided by 2, dissociation energy followed by electron gain enthalpy, where its sign is negative because it is an exothermic reaction. After the addition of electron, amount of energy is released during this reaction because it is an exothermic reaction. Okay, next delta H, next delta H, I just write this equation here. Delta H is equal to, first delta H sublimation followed by delta H ionization energy followed by delta H dissociation energy, that is divided by 2, followed by delta H electron gain enthalpy plus U, or it is minus U because lattice energy also, it is the amount of energy released ಆಗಿರೋದ್ರಿಂದ ಏನಾಗ್ತದೆ, that is exothermic in nature, that is why it carries a negative charge. Okay, next, this is how we can calculate the lattice energy of the system, lattice energy of ionic compounds. Okay, in this example means the preparation of a NaCl compound by using Born-Haber cycle. How we are going to calculate the lattice energy means by using the concepts of enthalpy of formation, by using the concepts of this sublimation, ionization, dissociation, electron gain enthalpy. Here, according to Hess law, the amount of energy liberated at a single step, it is exactly equal to the sum of the energies of all the reactions, sum of the energies of all the reactions. Okay, that is explained by this reaction. By using this condition, we are going to calculate the lattice energy of an ionic compound more easily. Okay, next, is it clear? Next, we will move on to one more example, that is formation of MgO, magnesium oxide, formation of MgO using Born-Haber cycle, where according to enthalpy of formation, the element ಏನಿರಬೇಕು, it should exist in a pure state plus half O2, it is in a gaseous state, it will become MgO. Okay, it is called enthalpy of formation, where an ionic compound is formed by the combination of elements in their pure state or a stable state. Okay, from this equation we are going to calculate what? The lattice energy. How do we calculate? What is our required equation then? Our required equation is Mg plus 2, means magnesium, it tends to lose how many electrons? 2 electrons. Then those 2 electrons are gained by this oxygen atom, finally they become a MgO. This is our required equation, and energy released during this reaction we can call it as a lattice energy, and energy released during this reaction is called enthalpy of formation, right? Okay, in order to convert this magnesium into magnesium cation, magnesium dication agi convert madlikke, what is the procedure we have used? In the last example you say that in order to convert this solid into gaseous state, first we have to convert this magnesium in a solid state into a magnesium into a gaseous state. That process is called what? That process is called sublimation. The process of conversion of solid state into gaseous state is called what? Sublimation, where the magnesium is converted into magnesium atom from its solid state to gaseous state. It is converted. Again, enthalpy of sublimation is positive because here this reaction is endothermic. Heat is absorbed by the system. Okay, followed by first, directly we cannot convert this magnesium ion into Mg+2 ion. We cannot remove both the electrons immediately. First we have to remove that one electron, followed by we have to remove one more electron. Okay, removal of two electrons at each time is not possible. First we have to convert this gaseous magnesium atom into Mg plus after losing this one electron. Mg after losing one electron, and the energy required to convert Mg to Mg plus or energy required to remove that electron is called what? Ionization energy. Here this energy is required for the removal of first electron ಆಗಿರೋದ್ರಿಂದ this is called first ionization energy. And delta H ionization energy is positive because ನಾವಿಲ್ಲಿ ಎನರ್ಜಿನ ಕೊಡ್ತಾ ಇದ್ದೇವೆ. Energy is positive, followed by we have to convert from this positive magnesium cation into Mg+2 ion. Mg+2 ion convert ಮಾಡಬೇಕು, so that we have to remove one more electron from magnesium cation. ಈ magnesium cation ಇಂದ ಇನ್ನೊಂದು ಎಲೆಕ್ಟ್ರಾನ್ ನ ರಿಮೂವ್ ಮಾಡಬೇಕು. There also we have to spend amount of energy. That energy is also nothing but the ionization energy. That energy required for the removal of a second electron from this magnesium cation, that is second ionization energy. ಈ ಎನರ್ಜಿಗಳನ್ನು ಸಕ್ಸೆಸಿವ್ ಅಯನೈಸೇಷನ್ ಎನರ್ಜೀಸ್ ಅಂತ ಕರೀತಾರೆ. ಓಕೆ, ಅಯನೈಸೇಷನ್ 1, ಅಯನೈಸೇಷನ್ ಎನರ್ಜಿ 2, ಅಯನೈಸೇಷನ್ ಎನರ್ಜಿ 3, ಈ ಥರ ಎನರ್ಜೀಸ್ ಬರ್ತಾ ಹೋದರೆ ಅವುಗಳನ್ನು ಸಕ್ಸೆಸಿವ್ ಅಯನೈಸೇಷನ್ ಎನರ್ಜೀಸ್ ಅಂತ ಕರೀತಾರೆ. ಓಕೆ, here we had prepared magnesium cation in its gaseous state. First thing is clear. First we have to convert that solid state magnesium atom or element into gaseous atom by the process of sublimation by applying amount of energy. That is why its delta H is positive, followed by from this gaseous cation we have gaseous atom, we have to convert it into a gaseous cation. The energy requirement for that reaction is called ionization energy, followed by from this gaseous monocation we have to convert this cation into Mg+2 ion by applying some more amount of energy, that is called second ionization enthalpy. Delta H ionization energy 2 is again positive, amount of energy is required. Okay, now Mg+2 is ready in its gaseous state. Now we will move on to oxygen atom. It is already existed in a gaseous state. No need to sublimate this oxygen molecule, but we have to dissociate molecule. As in the last reaction, this molecule undergoes dissociation like this. Dissociation of this molecule takes place. This bond ಅನ್ನು dissociate ಮಾಡಿಬಿಟ್ಟು ನಾವೇನು ಮಾಡ್ತೀವಿ, ಸಿಂಗಲ್ gaseous atom ಆಗಿ ಕನ್ವರ್ಟ್ ಮಾಡ್ತೀವಿ. Single gaseous atom it is converted into. Is it clear? Here in this reaction, conversion of oxygen atom, for this oxygen molecule no need of sublimation because it is already existed in a gaseous state. The only thing that we can do is we just dissociate this molecule into atom. The first step is over. We just convert that molecule into atomic state. Then in the second step, what is the work of oxygen here? It used to accept the electrons. Now how many electrons? It used to gain 2 electrons. In this step, first we have to provide one electron into this, and as I already explained in the last reaction, when an electron is added into the gaseous atom, then the change in enthalpy of that atom is nothing but electron gain enthalpy. ಯಾವಾಗ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಗೇಷಿಯಸ್ ಆಟಮ್ನ ವೇಲೆನ್ಸ್ ಶೆಲ್ಗೆ ಆ್ಯಡ್ ಆಗ್ತದೋ ಅಲ್ಲಿ ಎಂಥಾಲ್ಪಿ ವೇರಿಯೇಷನ್ಸ್ ಆಗುತ್ತೆ, ಚೇಂಜ್ ಆಗುತ್ತೆ, ಆ್ಯಂಡ್ ಎನರ್ಜಿ ಈಸ್ ರಿಲೀಸ್ಡ್ ಡ್ಯೂರಿಂಗ್ ದಟ್ ರಿಯಾಕ್ಷನ್. That energy is nothing but electron gain enthalpy. First electron gain enthalpy ಅಂತ ಹೇಳ್ಬೋದಾ, ಯಾಕೆಂದರೆ we need to add one more electron into this reaction, and this is converted into O minus 1. But what is our required oxygen? It should be in O2 O minus 2 state. Okay, in order to this we need to add one more electron and it will become O2 minus. Oxygen, after accepting one electrons it becomes O minus. After accepting one more electron it will become O2 minus ಆಗುತ್ತೆ. Okay, this is also in a gaseous state, and here you just remember this concept. Okay, this is more important. ಆವಾಗಲೇ ಹೇಳಿದ್ವಿ, when electron is added into the gaseous atom amount of energy is released ಅಂತ. ರಿಲೀಸ್ ಆಗಿರೋದ್ರಿಂದ ಇಲ್ಲಿ ಡೆಲ್ಟಾ ಹೆಚ್ ಏನಿರ್ತದೆ ಎಲೆಕ್ಟ್ರಾನ್ ಗೈನ್ ಎಂಥಾಲ್ಪಿ 1 ಇಂದು ನೆಗೆಟಿವ್ ಇರುತ್ತೆ. ಯು ಮಸ್ಟ್ ರಿಮೆಂಬರ್ ದಿಸ್. ಡೆಲ್ಟಾ ಹೆಚ್ electron gain enthalpy, first electron gain enthalpy is a negative, not positive, because energy is released during the reaction. But in a second ionization enthalpy or second gain electron gain enthalpy, ಇಲ್ಲಿ ನೋಡಿ ಆಲ್ರೆಡಿ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಇದೆ ಆಕ್ಸಿಜನಲ್ಲಿ, ಆಲ್ರೆಡಿ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನು ಆ್ಯಡ್ ಮಾಡಿದಿರಿ ಅಂದ್ಕೊಳ್ಳಿ, ಆಲ್ರೆಡಿ ಇಟ್ ಕ್ಯಾರೀಸ್ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್. ಆಫ್ಟರ್ ದಟ್ ಒನ್ ಮೋರ್ ಎಲೆಕ್ಟ್ರಾನ್ ಈಸ್ ಆ್ಯಡೆಡ್ ಇನ್ ಟು ದಿಸ್ ಆಕ್ಸಿಜನ್ ಅಂದ್ಕೊಳ್ಳಿ. ಆಲ್ರೆಡಿ ಇಲ್ಲಿ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಇರ್ತದೆ ದಟ್ ಕ್ಯಾರೀಸ್ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಇರುತ್ತೆ. ಆಕ್ಸಿಜನ್ಗೆ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಇರೋದ್ರಿಂದ ದಟ್ ಶೋಸ್ ದಿ ಎಲೆಕ್ಟ್ರಾನ್ ರಿಚ್ನೆಸ್. ದಿಸ್ ಎಲೆಕ್ಟ್ರಾನ್ ಈಸ್ ಆಲ್ಸೋ ಹ್ಯಾವಿಂಗ್ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್. ದಿಸ್ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಆ್ಯಂಡ್ ದಿಸ್ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ವಿಚ್ ಎಕ್ಸ್ಪೀರಿಯನ್ಸಸ್ ರಿಪಲ್ಸಿವ್ ಇಂಟ್ರಾಕ್ಷನ್. ಅಂದರೆ ಈಸಿಯಾಗಿ ಇನ್ನೊಂದು ಎಲೆಕ್ಟ್ರಾನನ್ನು ಈ O ಮೈನಸ್ ಆಟಮ್ಗೆ ಆ್ಯಡ್ ಮಾಡೋಕ್ಕಾಗೋದಿಲ್ಲ. okay, because of repulsive interactions between the added electron and the negative charge. ಈ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಮತ್ತು ಎಲೆಕ್ಟ್ರಾನ್ ಆ್ಯಡ್ ಮಾಡ್ತೀವಲ್ಲ ಅದ್ರ ನಡುವೆ ರಿಪಲ್ಸಿವ್ ಇಂಟ್ರಾಕ್ಷನ್ಸ್ ಆಗ್ತದೆ. ಓಕೆ, ನಾವು ಈ ರಿಪಲ್ಸಿವ್ ಇಂಟ್ರಾಕ್ಷನ್ ಅನ್ನು ಓವರ್ಕಮ್ ಮಾಡೋ ಥರ ನಾವು ಎನರ್ಜಿನ ಅಪ್ಲೈ ಮಾಡಬೇಕಾಗುತ್ತೆ. ವಿ ಹ್ಯಾವ್ ಟು ಅಪ್ಲೈ ದ ಎನರ್ಜಿ ಇನ್ ಆರ್ಡರ್ ಟು ರಿಮೂವ್ ದಿ repulsive interactions between this O minus and electron. Okay, that is why in this electron gain enthalpy there is no release of energy takes place, instead gaining of energy takes place. ಯಾಕೆ ಎನರ್ಜಿನ ಗೈನ್ ಮಾಡಬೇಕು? ಎಲೆಕ್ಟ್ರಾನ್ ಮತ್ತು ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ನಡುವಿನ ರಿಪಲ್ಸಿವ್ ಇಂಟ್ರಾಕ್ಷನ್ಸನ್ನು ಕಡಿಮೆ ಮಾಡಲಿಕ್ಕೆ. ರಿಪಲ್ಸಿವ್ ಇಂಟ್ರಾಕ್ಷನ್ಸ್ ಕಡಿಮೆ ಮಾಡಬೇಕು ಅಂದರೆ ಎನರ್ಜಿನ ಅಪ್ಲೈ ಮಾಡಬೇಕು. ಫಾರ್ ದ್ಯಾಟ್ ಪರ್ಪಸ್ ವಿ ಜಸ್ಟ್ ಆ್ಯಡ್ ಸಮ್ ಅಮೌಂಟ್ ಆಫ್ ಎನರ್ಜಿ ಟು ದಿಸ್ ಹಿಯರ್. ಡೆಲ್ಟಾ ಹೆಚ್ ಎಲೆಕ್ಟ್ರಾನ್ ಗೈನ್ ಎಂಥಾಲ್ಪಿ, ಸೆಕೆಂಡ್ ಎಲೆಕ್ಟ್ರಾನ್ ಗೈನ್ ಎಂಥಾಲ್ಪಿ ಈಸ್ ಪಾಸಿಟಿವ್. ಯು ಮಸ್ಟ್ ರಿಮೆಂಬರ್ ದಿಸ್. ಹಿಯರ್ ಫಸ್ಟ್ ಕೇಳ್ಬೋದು ನಿಮಗೆ ಪ್ರಶ್ನೆನ, why first ionization or first electron gain enthalpy is a negative and the second gain electron gain enthalpy is positive? ಯಾಕೆ? after the addition of a first electron amount of energy is released, but if you want while adding the second electron there is a repulsive interaction takes place between the electron and the negative charge of the oxygen ion. In order to avoid that repulsive interactions we need to apply the amount of energy. Instead the amount of energy release ಆಗೋದಿಲ್ಲ, ನಾವು ಎನರ್ಜಿನ ಅಪ್ಲೈ ಮಾಡಬೇಕಾಗ್ತದೆ. that is why this electron gain enthalpy is positive. now both the ions are ready now. Mg+2 in a gaseous state is ready and O2 O minus 2 in a gaseous state is ready. now the bond formed is called and the energy released is called lattice energy. ಇಲ್ಲಿ ಬಾಂಡ್ ಫಾರ್ಮ್ ಆಗಿರೋದು ಅಯಾನಿಕ್ ಬಾಂಡ್ ಆಗಿರ್ತದೆ. ಓಕೆ, ಹಿಯರ್ what is this whole equation explains? Whether this is the equation of lattice energy or enthalpy of formation. This equation represents the enthalpy of formation because which includes the formation of ionic compound by the combination of elements in their pure state. ಪ್ಯೂರ್ ಸ್ಟೇಟಲ್ಲಿ ಕಂಬೈನ್ ಆಗಿದೆ, ಇಲ್ಲಿ ರಿಲೀಸ್ ಆಗಿರ್ತಕ್ಕಂಥ ಎನರ್ಜಿ ಎಂಥಾಲ್ಪಿ ಆಫ್ ಫಾರ್ಮೇಷನ್ ಆಗಿರುತ್ತೆ. ಬಟ್ ಹಿಯರ್ 1 mole of a same compound is formed by the combination of gaseous cation and gaseous anion. Gaseous cation ಮತ್ತು gaseous anion ಆಗಿ combination ಆಗಿಬಿಟ್ಟು ನಮಗೆ ionic compound generate ಆಗಿದೆ, and energy released by this reaction is called lattice energy. Lattice energy. Okay, now how do we calculate the lattice energy of this reaction? ಯಾವ ಥರ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು? ಅಕಾರ್ಡಿಂಗ್ ಟು ವಿಚ್ ಲಾ? ಬೈ Hess's law. Hess law ಇಂದ ನಾವೇನು ಮಾಡ್ತೇವೆ? ಲ್ಯಾಟಿಸ್ ಎನರ್ಜಿ ಆಫ್ ದಿಸ್ ರಿಯಾಕ್ಷನ್ ಅನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೇವೆ. ವಾಟ್ ಇಟ್ ಸೇಸ್? Hess law, according to Hess law, energy liberated or energy released during this reaction or during this single step reaction is equal to sum of all the energies of the cycle, sum of all the energies of the system. Okay, now how do we calculate the lattice energy for this system? Means delta H is equal to, which is the first reaction here? Enthalpy of sublimation. Enthalpy of sublimation plus, next, enthalpy of first ionization enthalpy. Second one, enthalpy of second ionization enthalpy plus, third ಏನಪ್ಪಾ? Dissociation. Next, enthalpy of dissociation divided by 2 followed by electron gain enthalpy ಅಲ್ವಾ? This is first electron gain enthalpy. ಏನು ಇಂಡಿಕೇಟ್ ಮಾಡ್ತದೆ? It releases the energy during the reaction. That means this is negative charge. It carries first electron gain enthalpy and second electron gain enthalpy. Because of repulsive interactions, it does not releases the energy. Instead, it can gains the energy. That is why it is represented as delta Eg2 minus U. U means the lattice energy. Lattice energy means energy released. ಅದಕ್ಕೆ negative charge ಬಂದಿದೆ. This is how we can calculate the lattice energies of ionic compounds by sum up of all the energies of the system. ಎಲ್ಲ ಎನರ್ಜಿ ಈ ಸಿಸ್ಟಮಲ್ಲಿ ಬರ್ತಕ್ಕಂಥ ಎಲ್ಲ ಎನರ್ಜೀಸನ್ನು ಸಮ್ ಅಪ್ ಮಾಡಿಬಿಟ್ಟು ನಾವು ಲ್ಯಾಟಿಸ್ ಎನರ್ಜಿಯನ್ನು ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ತೀವಿ. Okay, this is how we can calculate the lattice energy. Okay, then what are the factors that affects the lattice energy? What are the factors that affects the lattice energy? ಯಾವ ಫ್ಯಾಕ್ಟರ್ಸ್ ಅಫೆಕ್ಟ್ ಮಾಡ್ತದೆ? factors affecting lattice energy. Okay, lattice energy ಯಾವುದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಇರ್ತದೆ? ಯೂಶಲಿ lattice energy depends upon the strength of atoms or strength of the bonds. Okay, NaCl plus minus, ಇವುಗಳ ನಡುವೆ ನೇಚರ್ ಆಫ್ ಬಾಂಡ್ ಏನಿರ್ತದೆ ಅಥವಾ ನೇಚರ್ ಆಫ್ ಫೋರ್ಸ್ ಏನಿರ್ತದೆ? ಇಟ್ ಈಸ್ ಅ ಸ್ಟ್ರಾಂಗ್ ಎಲೆಕ್ಟ್ರೋಸ್ಟ್ಯಾಟಿಕ್ ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ನ, ಹೌದಲ್ವಾ? ಅಯಾನಿಕ್ ಬಾಂಡ್ ನಡುವೆ ಯಾವ ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ ಇರುತ್ತೆ? ಸ್ಟ್ರಾಂಗ್ ಎಲೆಕ್ಟ್ರೋಸ್ಟ್ಯಾಟಿಕ್ ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್. ಈ ಬಾಂಡ್ ಎಷ್ಟು ಸ್ಟ್ರಾಂಗ್ ಆಗ್ತಾ ಹೋಗ್ತದೆ ಅಷ್ಟು ಲ್ಯಾಟಿಸ್ ಎನರ್ಜಿ ಆಫ್ ದಿ ಅಯಾನಿಕ್ ಕಾಂಪೌಂಡ್ ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋಗ್ತದೆ. ಓಕೆ, ದ ಸ್ಟ್ರೆಂತ್ ಆರ್ ದ ಫೋರ್ಸ್, electrostatic force in between the ions is directly proportional to lattice energy. As the force or electrostatic force between the ions increases, lattice energy also increases. Then this force is represented by a formula K Q1 Q2 by R square. Okay, this is the formula which represents the electrostatic force between the ionic compounds. Okay, here ನಾವು ಆವಾಗಲೇ ಹೇಳಿದ್ವಿ ಫೋರ್ಸ್ ಆ್ಯಂಡ್ ಲ್ಯಾಟಿಸ್ ಎನರ್ಜಿ ಆರ್ ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಅಂತ. ಫೋರ್ಸ್ ಜಾಸ್ತಿ ಆದರೆ ಲ್ಯಾಟಿಸ್ ಎನರ್ಜಿ ಜಾಸ್ತಿ ಆಗ್ತದೆ ಅಂತ. ಹಿಯರ್ ಅಕಾರ್ಡಿಂಗ್ ಟು ದಿಸ್ ಇಕ್ವೇಷನ್, ಫಸ್ಟ್ factor that affects the lattice energy is lattice energy is directly proportional to charges na. Q1 Q2 are the charges, directly proportional to ಚಾರ್ಜಸ್ ಅಂದ್ರೆ ಏನಪ್ಪ, ಈ ಕ್ಯಾಟಯಾನ್ ಮತ್ತು ಆನಯಾನ್ನ ಚಾರ್ಜಸ್ ಎಷ್ಟು ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋಗ್ತದೋ ಅಷ್ಟು ಲ್ಯಾಟೈಸ್ ಎನರ್ಜಿ ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋಗ್ತದೆ. ಓಕೆ, ಲ್ಯಾಟೈಸ್ ಎನರ್ಜಿ ಇಟ್ ಡಿಪೆಂಡ್ಸ್ ಅಪಾನ್ ದಿ ಚಾರ್ಜಸ್. ಎಷ್ಟು ಚಾರ್ಜ್ ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋಗುತ್ತೋ ಅಷ್ಟು ಈ ಲ್ಯಾಟೈಸ್ ಎನರ್ಜಿ ಜಾಸ್ತಿ ಆಗ್ತದೆ. ಫಾಲೋಡ್ ಬೈ ಆರ್ ಮೀನ್ಸ್ ಡಿಸ್ಟೆನ್ಸ್ ಅಲ್ವಾ, ಆರ್ ಸೈಜ್ ವಿ ಕ್ಯಾನ್ ಕನ್ಸಿಡರ್. ಲ್ಯಾಟೈಸ್ ಎನರ್ಜಿ is inversely proportional to size. These two things you must remember. Lattice energy is directly proportional to charge and it is inversely proportional to size. Okay, if you take an example, ಒಂದಷ್ಟು ಎಕ್ಸಾಂಪಲ್ ಕೊಟ್ಟರು ಅಂದ್ಕೊಳ್ಳಿ. If you give example like this, LiCl, NaCl, KCl, then RbCl. ಓಕೆ, ಈ ಎಕ್ಸಾಂಪಲನ್ನು ಕೊಟ್ಟು ಐಡೆಂಟಿಫೈ ವಿಚ್ ಅಯಾನಿಕ್ ಕಾಂಪೌಂಡ್ ಪೊಸೆಸ್ ಹೈಯರ್ ಲ್ಯಾಟೈಸ್ ಎನರ್ಜಿ ಅಂತ ಕೇಳಿದರು ಅಂದ್ಕೊಳ್ಳಿ. ಆರ್ ಅರೇಂಜ್ ದಿಸ್ ಸೀರೀಸ್ ಇನ್ ದಿ ಇನ್ಕ್ರೀಸಿಂಗ್ ಆರ್ಡರ್ ಆಫ್ ಲ್ಯಾಟೈಸ್ ಎನರ್ಜಿ ಅಂತ ಕೇಳಿದರು ಅಂದ್ಕೊಳ್ಳಿ. ಹೌ ಕ್ಯಾನ್ ವಿ ಸಾಲ್ವ್ ದಿಸ್? ಫಸ್ಟ್ ವಿ ಹ್ಯಾವ್ ಟು ಕನ್ಸಿಡರ್ ದ ಸೈಜ್. ನೋಡಿ, ಇಲ್ಲಿ ಆಲ್ ದ ಆನಯನ್ಸು ಸೇಮ್ ಇದೆ, ಹಾಗಾಗಿ ಸೇಮ್ ಸೈಜ್ ಇರ್ತದೆ. ಫಾಲೋಡ್ ಬೈ ಇಫ್ ಯು ಕನ್ಸಿಡರ್ ದ ಸೈಜ್ ಆಫ್ ಕ್ಯಾಟಯಾನ್ ಹೇಗಿರ್ತದೆ? ಲಿಥಿಯಂ, ಸೋಡಿಯಂ, ಪೊಟ್ಯಾಷಿಯಂ, ರುಬಿಡಿಯಂ, ಸೀಸಿಯಂನ. ಓಕೆ, ಡೌನ್ ದ ಗ್ರೂಪ್ ಅಟಾಮಿಕ್ ಸೈಜ್ ಏನಾಗ್ತದೆ? ಅಟಾಮಿಕ್ ಸೈಜ್ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತದೆ. ದಟ್ ಮೀನ್ಸ್ ಇನ್ ದಿಸ್ ಸೀರೀಸ್ ವಿಚ್ ಈಸ್ ದ ಎಲಿಮೆಂಟ್ ವಿಚ್ ಪೊಸೆಸ್ ಮೋರ್ ಅಟಾಮಿಕ್ ಸೈಜ್ ಇರೋದು ರುಬಿಡಿಯಂಗೆ. ಮೋರ್ ಅಟಾಮಿಕ್ ಸೈಜ್ ಇದೆ ಅಂತಂದರೆ ಲ್ಯಾಟೈಸ್ ಎನರ್ಜಿ ಯಾವುದಕ್ಕೆ ಕಡಿಮೆ ಇರ್ತದೆ? ರುಬಿಡಿಯಂ ಕ್ಲೋರೈಡ್. RbCl is the ionic compound which possess a less amount of ionic or less strength in its ionic bond and which possess a less lattice energy. Then what is the order? Which is the compound which possess higher lattice energy? Andre this lithium chloride, because size of lithium is small here. Size of lithium small ide. Size and lattice energy are inversely proportional. As the size of the molecule decrease ಆಗ್ತಾ ಇದೆ ಅಂತಂದರೆ then lattice energy ಏನಾಗ್ತದೆ? ಇನ್ಕ್ರೀಸ್ ಆಗ್ತದೆ. ಓಕೆ, that is why in this series lithium chloride it acts as a stronger ionic compound or lattice energy. Strength of the bond between these two is more than this and this. Okay, these 2 points, you just remember these 2 points. This is the most important points from the competitive point of view, where that type of questions will be asked, and while asking that question, so you just remember these 2 things, and by using these 2 things we can easily answer them. Okay, next. Is it clear regarding the concepts of lattice energy? What is meant by lattice energy, and what is the difference between lattice energy and enthalpy of formation? Then what is meant by Hess law? How do we calculate the lattice energy of an ionic compounds by using Hess law? These are all the concepts that we had discussed, and the next concept we will move on to covalent bonding or covalent bond. This is called a covalent bond. What is meant by this word covalent bond? How does this bond is going to be formed? ಯಾವ ಥರ ಈ ಬಾಂಡ್ ಫಾರ್ಮೇಷನ್ ಆಗ್ತದೆ? This bond is formed by the bond formed by the mutual sharing of electrons. Mutual sharing of electrons between 2 atoms. Or ಇದನ್ನ ಇನ್ನೊಂದು ಥರ ಡಿಫೈನ್ ಮಾಡ್ಬೋದು. It is the force of attraction which arises due to the mutual sharing of electrons between the two atoms. If we consider these two atoms, if there is a mutual sharing of electrons takes place by both the atoms, this atom can share its electrons and this atom can also share its electrons, thereby the formation of a bond takes place that a resulting bond is nothing but a covalent bond. Here in this bond there is no transfer of electrons, there is no loss of electrons, or there is no gain of electrons takes place. Instead here the mutual sharing of electrons takes place. ಇಲ್ಲಿ ಯಾವುದೇ ರೀತಿ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಟ್ರಾನ್ಸ್ಫರ್ ಆಗೋದಿಲ್ಲ, ಯಾವುದೇ ರೀತಿ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಲಾಸ್ ಆರ್ ಗೇನ್ ಆಗೋದಿಲ್ಲ. ಇನ್ಸ್ಟೆಡ್ ದ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಆರ್ ಶೇರ್ಡ್ ಇನ್ ಬಿಟ್ವೀನ್ ದ ಆಟಮ್ಸ್. ಓಕೆ, ದೆನ್ ವಾಟ್ ಆರ್ ದ ಕಂಡೀಷನ್ಸ್ ಫಾರ್ ದಿಸ್ ಕೋವಲೆಂಟ್ ಬಾಂಡ್? ಕೋವಲೆಂಟ್ ಬಾಂಡ್ ಆಗಬೇಕು ಅಂದರೆ ಏನು ಕಂಡೀಷನ್ಸ್ ಇರಬೇಕು? ಓಕೆ, ಬೋತ್ ದ atoms must be non-metals. Okay, this is the most important condition. If the bond is formed in between non-metals, if we consider these two non-metals, these two atoms, if both are non-metal only, there is a provision to form a covalent bond. If out of any one atom, if one is metal and another one is non-metal, means what is the nature of the bond here? One is metal, another one is non-metal. Metal means what is the nature of metal? It always tends to lose the electrons. What is the nature of non-metal? It always tends to gain the electrons, thereby the generation of charges takes place, followed by the formation of ionic bond takes place. But in order to form a covalent bond, we should make use of what? Both should be non-metals. A bond which is formed in between a non-metal and a non-metal, that is called what? Covalent bond. Okay, followed by the next, the electronegativity difference. Electronegativity difference between two atoms. Electronegativity between two atoms should be less than 1.7. ನಾನು ಅಯಾನಿಕ್ ಬಾಂಡನ್ನು ಡಿಸ್ಕಸ್ ಮಾಡುವಾಗ ಹೇಳಿದ್ದೆ, ಯಾವ ಬಾಂಡ್ಗಳು ಅಯಾನಿಕ್ ಆಗಿರುತ್ತೆ ಅಂದರೆ those electronegativity is greater than 1.7. If we consider these two atoms in which the electronegativity difference between these two atoms, if it less than 1.7 ಗಿಂತ ಕಡಿಮೆ ಇದ್ದರೆ ಆ ಬಾಂಡ್ ಕೋವಲೆಂಟ್ ಆಗಿರುತ್ತೆ. ಇಫ್ ಇಟ್ ಈಸ್ ಗ್ರೇಟರ್ ದೆನ್ 1.7, ದೆನ್ ಇಟ್ ಶೋಸ್ ದಿ ಪೋಲಾರ್ ಕ್ಯಾರೆಕ್ಟರ್ ಆರ್ ಇಟ್ ಶೋಸ್ ದಿ ಅಯಾನಿಕ್ ಬಿಹೇವಿಯರ್. ಅಯಾನಿಕ್ ಬಾಂಡ್ಸನ್ನು ಎಕ್ಸಿಕ್ಯೂಟ್ ಮಾಡುತ್ತೆ. ಓಕೆ, ದಿಸ್ ಈಸ್ ದ ಅನದರ್ ಕಂಡೀಷನ್ ದಟ್ ಇನ್ ಆರ್ಡರ್ ಟು ಫಾರ್ಮ್ ಅ ಕೋವಲೆಂಟ್ ಬಾಂಡ್, electronegativity difference between the two atoms, that should be less than 1.7. These 2 points you must remember. If the bond is formed between the two non-metals, then it is covalent, and if their electronegativity difference is less than 1.7, then it is covalent in nature. Then this covalent bond, which can be divided into two types, it is having two types. The first one, it is a polar covalent bond anta karitare, followed by second one, it is non-polar covalent bond. Here what is meant by these two? Polar covalent bond, non-polar covalent bond. ಏನು ನಾವು ಹೇಳಿದ್ವಿ, the bond is formed in between the two non-metals ಅಂತಂದರೆ what is the significance of this? Polar ಅಂದರೆ there is a generation of charges ಇರಬೇಕು. ಪ್ಯೂರ್ಲಿ ಕೋವಲೆಂಟ್ ಇದ್ದಾಗ ಚಾರ್ಜಸ್ ಎಲ್ಲಿಂದ ಬರುತ್ತೆ? ಹೌ ಕ್ಯಾನ್ ಇಟ್ ಬಿಕಮ್ ಅ ಪೋಲಾರ್ ಅನ್ನೋ ಡೌಟ್ಸ್ ಬರುತ್ತೆ. ಐ ಕ್ಯಾನ್ ಎಕ್ಸ್ಪ್ಲೈನ್ ಇಟ್ ಹಿಯರ್. Polar covalent bond means that includes unequal sharing of electrons, unequal sharing of electrons between the atoms. Okay, polarity ಯಾವಾಗ ಡೆವಲಪ್ ಆಗ್ತದೆ ಅಂತಂದರೆ ಅನ್ಈಕ್ವಲ್ ಶೇರಿಂಗ್ ಯಾವಾಗ ಆಗ್ತದೆ? ಯಾವುದೋ ಒಂದು ಆಟಮ್ ಜಾಸ್ತಿ ಹೇಳ್ಕೊಳ್ತದೆ, ಇನ್ನೊಂದು ಯಾವುದೋ ಆಟಮ್ ಕಡಿಮೆ ಹೇಳ್ಕೊಳ್ತದೆ ಅಂತಂದರೆ ಯಾವಾಗ ಆಗ್ತದೆ ಇದೆಲ್ಲ? ವೆನ್ ದೆರ್ ಈಸ್ ಅನ್ ಎಲೆಕ್ಟ್ರೋನೆಗೆಟಿವಿಟಿ ಡಿಫ್ರೆನ್ಸ್ ಬಿಟ್ವೀನ್ ದೆಮ್. If two atoms, if we consider a covalent bond between two atoms, out of those two atoms, in these two atoms, this atom possesses electronegativity, more electronegativity ಅನ್ಕೊಳ್ಳಿ. ಆಗೇನಾಗ್ತದೆ, in between this one bond is there, a covalent bond, ಆ ಬಾಂಡಲ್ಲಿ ಇರ್ತಕ್ಕಂಥ ಬಾಂಡೆಡ್ ಪೇರ್ ಎಲೆಕ್ಟ್ರಾನ್ಸು they tends to move towards more electronegative atom. ಯಾವ ಆಟಮ್ಗೆ ಎಲೆಕ್ಟ್ರೋನೆಗೆಟಿವಿಟಿ ಜಾಸ್ತಿ ಇರ್ತದೋ ಆ ಕಡೆ ಅದು ಮೂವ್ ಆಗಲಿಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಗ್ತದೆ. and there, due to that movement of electrons or attraction of electrons, there is a generation of partial negative charges on this. Okay, there is a generation of polarity, or there is a generation of ionic character. Ionic character develop ಆಗ್ತದೆ covalent bond ಅಲ್ಲಿ ಯಾವಾಗ? when there is a difference in their electronegative atoms are combined together. Then second one, non-polar covalent bond. Non-polar covalent bond ಅಂದ್ರೆ it is formed by the equal sharing of electrons. Equal sharing of electrons. Equal sharing ಯಾವಾಗ ಆಗ್ತದೆ? if both the atoms possess the same electronegativity difference. ಯಾವುದಕ್ಕೂ ಎಲೆಕ್ಟ್ರೋನೆಗೆಟಿವಿಟಿ ಜಾಸ್ತಿ ಇಲ್ಲ, ಒಂದಕ್ಕೆ ಜಾಸ್ತಿ ಒಂದಕ್ಕೆ ಕಡಿಮೆ ಇದ್ದರೆ ಏನಾಗ್ತದೆ? ಯಾವುದಕ್ಕೆ ಜಾಸ್ತಿ ಎಲೆಕ್ಟ್ರೋನೆಗೆಟಿವಿಟಿ ಇರ್ತದೋ ಆ ಕಡೆ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಮೂವ್ ಆಗುತ್ತೆ. ಬಟ್ ಹಿಯರ್, if both the atoms are having same electronegativity difference, then the moment of electron density, it remains as it is. It either move towards any one of the atoms. ಯಾವ ಕಡೆನೂ ಇದು ಮೂವ್ ಆಗೋದಿಲ್ಲ. in such cases the resulting covalent bond is called a non-polar covalent bond. okay, ಈ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ನಾನು ಮತ್ತೆ ತಗೋತೀನಿ. here there are two types of covalent bond. polar covalent bond, it is formed by the unequal sharing of electrons. ಯಾವಾಗ ಅನ್ಈಕ್ವಲ್ ಶೇರ್ ಆಗ್ತದೆ? ಎಲೆಕ್ಟ್ರೋನೆಗೆಟಿವಿಟಿ ಡಿಫ್ರೆನ್ಸಸ್ ಇದ್ದಾಗ. ಹಿಯರ್ ನಾನ್ ಪೋಲಾರ್ ಕೋವೆಲೆಂಟ್ ಬಾಂಡ್, ಇಟ್ ಇನ್ಕ್ಲೂಡ್ಸ್ ದ ಈಕ್ವಲ್ ಶೇರಿಂಗ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್. ಯಾವಾಗ ಈಕ್ವಲ್ ಶೇರಿಂಗ್ ಆಗ್ತದೆ? ದೇರ್ ಈಸ್ ಅ ಸಿಮಿಲರ್ ಡಿಫ್ರೆನ್ಸ್ ಇನ್ ದೇರ್ ಎಲೆಕ್ಟ್ರೋನೆಗೆಟಿವಿಟಿ, ಜಾಸ್ತಿನೂ ಇಲ್ಲ ಕಡಿಮೆನೂ ಇಲ್ಲ, ಆವಾಗ ನಾನ್ ಪೋಲಾರ್ ಕೋವೆಲೆಂಟ್ ಬಾಂಡ್ ಬರ್ತದೆ. ಓಕೆ, ನಾವು what are the examples of this covalent bond? How do this covalent bond is going to be formed? First one, formation of H2 molecule. Formation of H2 molecule. Okay, H2 molecule ಹೇಗೆ ಫಾರ್ಮೇಷನ್ ಆಗುತ್ತೆ? Okay, hydrogen atom you can consider. Okay, atomic number of hydrogen is what? 1. It is having the configuration of 1s1. It requires how many electrons to get the stable electronic configuration? ಹೈಡ್ರೋಜನ್ಗೆ ನಿಯರೆಸ್ಟ್ ನೋಬಲ್ ಗ್ಯಾಸ್ ಯಾವುದಿದೆ? ಹೀಲಿಯಂ ಇದೆ. ಹೀಲಿಯಂ ಕಾನ್ಫಿಗರೇಷನ್ ಎಷ್ಟಿರುತ್ತೆ? 1s2 ಇರುತ್ತೆ. ಇನ್ ಆರ್ಡರ್ ಟು ಗೆಟ್ ದ ಕಾನ್ಫಿಗರೇಷನ್ ಆಫ್ ಹೀಲಿಯಂ, ಹೈಡ್ರೋಜನ್ ರಿಕ್ವೈರ್ ಒನ್ ಮೋರ್ ಎಲೆಕ್ಟ್ರಾನ್. ಬಟ್ ಇನ್ ಆರ್ಡರ್ ಟು ಗೆಟ್ ದಟ್ ಎಲೆಕ್ಟ್ರಾನ್, ಹೈಡ್ರೋಜನ್ನು ಎಲೆಕ್ಟ್ರಾನನ್ನು ಕಳ್ಕೊಳ್ಳೋದಿಲ್ಲ ಅಥವಾ ಎಲೆಕ್ಟ್ರಾನನ್ನು ಡೈರೆಕ್ಟಾಗಿ ಪಡ್ಕೊಳ್ಳೋದಿಲ್ಲ. ಇಫ್ ಇಟ್ ಲೂಸಸ್ ದಿಸ್ ಒನ್ ಎಲೆಕ್ಟ್ರಾನ್ ಅಂದ್ಕೊಳ್ಳಿ, ಹೈಡ್ರೋಜನಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನೇ ಇರೋದಿಲ್ಲ, ಆವಾಗ ಅದು ಇಂಡಿಪೆಂಡೆಂಟ್ ಎಕ್ಸಿಸ್ಟೆನ್ಸ್ ಆಗೋದಿಲ್ಲ. ದಟ್ ಈಸ್ ವೈ ಹೈಡ್ರೋಜನ್ ಏನು ಮಾಡ್ತದೆ? ಈ ಒನ್ ಎಲೆಕ್ಟ್ರಾನನ್ನು ನಾನು ಒಂದು ಡಾಟ್ ಆಗಿ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತೇನೆ. ದಿಸ್ ಡಾಟ್ ರೆಪ್ರೆಸೆಂಟ್ಸ್ ದಿ ಎಲೆಕ್ಟ್ರಾನ್ ಪ್ರೆಸೆಂಟ್ ಇನ್ ದ ವ್ಯಾಲೆನ್ಸ್ ಶೆಲ್. ಆ್ಯಂಡ್ ಒನ್ ಮೋರ್ hydrogen is also atomic number 1. It is having 1s1 configuration. I can write it here. Hydrogen, it is having 1s1 configuration. I can represent this hydrogen like this. ಎರಡೂ ಹೈಡ್ರೋಜನಲ್ಲೂ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಇದೆ. ಎರಡೂ ಹೈಡ್ರೋಜನನ್ನು ನಾನು ಈ ಥರ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡಿದ್ದೇನೆ. ದೆನ್ ಇವಾಗ ಏನಾಗ್ತದೆ? ಇನ್ಸ್ಟೆಡ್ ಆಫ್ ಲೂಸಿಂಗ್ ಆರ್ ಗೈನಿಂಗ್ ದ ಎಲೆಕ್ಟ್ರಾನ್, ಎರಡೂ ಎಲೆಕ್ಟ್ರಾನ್ಗಳ ನಡುವೆ ಅಥವಾ ಎರಡೂ ಆಟಮ್ಸ್ಗಳ ನಡುವೆ ಗೈನಿಂಗ್ ಆರ್ ಲಾಸಿಂಗ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಆಗೋದ್ರ ಬದಲು ದೇರ್ ಈಸ್ ಅ ಮ್ಯೂಚುವಲ್ ಶೇರಿಂಗ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಟೇಕ್ಸ್ ಪ್ಲೇಸ್. Mutual sharing of electrons means these two bonded pair electrons, ಯಾವ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಬಾಂಡಿಂಗಲ್ಲಿ ಇನ್ವಾಲ್ವ್ ಆಗಿರ್ತಾವೋ ಅವು ಬಾಂಡೆಡ್ ಪೇರ್ಸ್ ಆಗಿರುತ್ತೆ. ಆ್ಯಂಡ್ ದೀಸ್ ಟು ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಆರ್ ರೆಸ್ಪಾನ್ಸಿಬಲ್ ಫಾರ್ ಬೋತ್ ದ ಆಟಮ್ಸ್. ದಿಸ್ ಹೈಡ್ರೋಜನ್ ರಿಕ್ವೈರ್ಸ್ 2 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ನ. ಈ ಎರಡೂ ಎಲೆಕ್ಟ್ರಾನು ಈ ಹೈಡ್ರೋಜನ್ಗೂ ಈಕ್ವಲ್ ಇರುತ್ತೆ, ಈ ಹೈಡ್ರೋಜನ್ಗೂ ಈಕ್ವಲ್ ಇರುತ್ತೆ. These two electrons are responsible for this hydrogen also and this hydrogen also. In this way they can attain the stable electronic configuration. Okay, this is what is the nature of this bond. Covalent bond. Enta covalent bond idu? Single covalent bond, double covalent bond, triple covalent bond. It is an example for a single covalent bond. Yake? The covalent bond which is formed by the mutual sharing of single electron pairs. Single electron pairs. I repeat, the covalent bond is formed by the combination of or mutual sharing of single electron pairs. Adenagirutte single covalent bond agirutte. If the same covalent bond is formed by the mutual sharing of two electron pairs adre adenagutte double covalent bond agutte. If the same thing is repeated for 3 electron pairs, then it becomes a triple covalent bond. Like that, if only one electron pair is shared between these two atoms, that is why this is an example for a single covalent bond. Single covalent bond. Single covalent bond. Okay, now avagla ಎರಡು ಟೈಪ್ಸ್ ಹೇಳಿದ್ವಿ covalent bond ಅಲ್ಲಿ. Polar covalent bond and non-polar covalent bond. Okay, and this molecule, hydrogen molecule, yaudಕ್ಕೆ belong ಆಗುತ್ತೆ? Whether it belongs to a polar covalent bond or a non-polar covalent bond? Yes, it is belongs to non-polar covalent bond because the electronegativity difference of hydrogen, both the atoms are same, na? Both are having same electronegativity difference, and the movement of electrons, it takes place neither towards this hydrogen nor towards this hydrogen. Yav kadenu movement agodilla because of their same electronegativity difference, and its electron density is there as it is. That is why it is an example for what? Non-polar covalent bond. Non-polar covalent bond agirutte. This is an example for non-polar covalent bond. The only thing that you must remember is the difference in their electronegativity. If the electronegativity difference is more, then it results in a polar covalent bond. If both are having same electronegativity difference, the resulting bond is non-polar covalent bond. Okay, this is regarding the formation of H2 molecule. Okay, is it clear? Next, second one, formation of a hydrogen fluoride molecule. Formation of HF molecule. HF molecule. Okay, here hydrogen, atomic number is 1, configuration is 1s1. It is represented as like this, followed by fluorine atom, atomic number is 9, and its configuration is a 1s2, 2s2 excuse, 1s2, 2s2, 2p5 it is, and it consists of how many electrons in its valence shell? In its valence shell, it is having 7 electrons, and it requires how many electrons to get the octet? It requires only 1 electron to get the octet. Okay, it is represented as like this: 1, 2, 3, 4, 5, 6 and 7. These represents the number of electrons present in the valence shell of a fluorine atom. Okay, then now we should consider like this: fluorine atom, 1, 2, 3, 4, 5, 6. Okay, this 1 dot represents hydrogen is having only 1 electron, and this 7 dots represents that the fluorine atom in its valence shell, which consists of 7 electrons. Here this fluorine atom, this requires only 1 electron to get the stability or to get the octet configuration. At the same time, this hydrogen atom also requires only 1 electron to get the nearest noble gas configuration, that is duplet configuration. Okay, now there is a formation of a one covalent bond takes place, mutual sharing of bonds takes place here. Okay, ಇವೆರಡರ ನಡುವೆ ಏನಾಗ್ತದೆ? ಫಾರ್ಮೇಷನ್ ಆಫ್ ಬಾಂಡ್ ಟೇಕ್ಸ್ ಪ್ಲೇಸ್. ಒನ್ ಇಸ್ ಹೈಡ್ರೋಜನ್ ಆಟಮ್, another one is fluorine atom. ಇವುಗಳ ನಡುವೆ ಫಾರ್ಮೇಷನ್ ಆಗೋ ಬಾಂಡ್ ಏನಾಗಿರ್ತದೆ? HF ಬಾಂಡ್ ಇಟ್ ಈಸ್. ಓಕೆ, HF F, this is covalent bond 1 2 3 4 5 6. Okay, this is the covalent bond. Then whether this is a single covalent bond or a double covalent bond, this is an example for a single covalent bond, because in between these two atoms, how many pair of electrons are shared here? Only one pair of electrons are shared between these two. That is why this is an example for a single covalent bond. This is an example for single covalent bond. Single covalent bond. Right. Next. Which type of covalent bond it can represent, whether it belongs to polar covalent bond or non-polar covalent bond. As I already explained, if both the atoms are having same electronegativity, then it is an example for non-polar covalent bond, and in between them equal sharing of electrons are there. But here fluorine and hydrogen both are having a differ in their electronegativities. Electronegativity of fluorine is much higher than hydrogen. In such cases, what happens? This more electronegative atom, which tends to grab its electron density, which tends to attract the electron density towards itself. ಈ ಕಡೆ ಎಲೆಕ್ಟ್ರಾನ್ಸನ್ನು ತನ್ನ ಕಡೆ ಎಳ್ಕೊಳ್ಳುತ್ತೆ. ಎಳ್ಕೊಂಡಾಗ ಏನಾಗ್ತದೆ? ಇಟ್ ಕ್ಯಾರೀಸ್ ಸ್ಲೈಟ್ಲಿ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್, ಇಟ್ ಕ್ಯಾರೀಸ್ ಸ್ಲೈಟ್ಲಿ partial negative charges and partial positive charges are there. This is not a complete charge. Okay, complete sign idagirodilla. This is a partial charge. Okay, where why it accepts the electrons? Because of its electronegativity. More electronegativity irodrinda enagutte, electrons na tan kade tagolutte. Electrons tan kade tagondmele it carries a partial positive charge, it carries a partial negative charge. Illi in between these two atoms, ಯಾವುದೋ ಒಂದು ಆಟಮ್ ಎಲೆಕ್ಟ್ರಾನ್ಸನ್ನು ಜಾಸ್ತಿ ತಗೊಳ್ತಾ ಇದೆ, ಯಾವುದೋ ಒಂದು ಆಟಮ್ ಎಲೆಕ್ಟ್ರಾನ್ಸನ್ನು ಬಿಟ್ಕೊಡ್ತಾ ಇದೆ ಅಂತಂದರೆ, ವೆದರ್ ಇಟ್ ಬಿಲಾಂಗ್ಸ್ ಟು ಈಕ್ವಲ್ ಶೇರಿಂಗ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಆರ್ ಅನ್ಈಕ್ವಲ್ ಶೇರಿಂಗ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್? Yes, it is belongs to unequal sharing of electrons takes place. If there is an unequal sharing of electrons, means which type of bond it belongs to? It belongs to polar covalent bond. It belongs to polar covalent bond. ಇದನ್ನು ನಾವು polar covalent bond ಅಂತ ಕರಿತೀವಿ. This is how in case of covalent bond there is a generation of ionic behavior. In this cases ಕೋವಲೆಂಟ್ ಬಾಂಡ್ಸು ಸ್ವಲ್ಪ ಅಯಾನಿಕ್ ಕ್ಯಾರೆಕ್ಟರ್ನ ಎಕ್ಸಿಬಿಟ್ ಮಾಡ್ತವೆ. ಯಾಕೆ ಎಕ್ಸಿಬಿಟ್ ಮಾಡುತ್ತೆ? ಬಿಕಾಸ್ ಆಫ್ ದ ಡಿಫರೆನ್ಸ್ ಇನ್ ದ electronegativities. Okay, because of the share of single electron pair here, it is an example for a single covalent bond. Because of the difference in their electronegativities, moment of electrons takes place towards one of the atoms such that it is an unequal distribution of electrons takes place. That is why it belongs to polar covalent bond. Okay, it is regarding the formation of HF molecule. How about the formation of covalent bond, and how the polarity or how the ionic character develops inside the covalent bond. Okay, next we will move on to the double covalent bond system, that is formation of that is the next concept, that is formation of O2 molecule, that is oxygen molecule, formation of O2 molecule. Next, what is meant by this? Oxygen molecule which is formed by the combination of two oxygen atoms. Okay, one oxygen atom. Okay, what is the atomic number of oxygen here? Atomic number of oxygen is 8. It is having the configuration of 1s2, 2s2 and 2p4 it is. And this oxygen which contains how many electrons in its valence shell? It consists of 6 electrons in its valence shell, and those 6 electrons are represented as like this: 2 4 6 2 4 6. Okay, what are these symbols indicates? These symbols indicates the number of electrons present in the valence shell of oxygen. Okay, here we have one more oxygen. That oxygen also having the same. That oxygen also have same 6 number of electrons or valence electrons in its valence shell. Okay, now one oxygen which contains 8 electrons plus one more oxygen which contains again 6 electrons. This oxygen contains 6 electrons. This oxygen also contains 6 electrons. But both the oxygens requires 2 more electrons or 4 electrons. Here this oxygen atom 2, 4, 6 and it requires 2 more electrons to get the stability. At the same time, this oxygen also requires 2, 4, 6 means it requires another 2 more electrons to get the stability. How can they get their stability? By forming a bond between them, that is covalent bond between them. Okay, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, in order to get the stable electronic configuration, there is a generation of 2 covalent bonds between the oxygen molecule. Okay, here now count the number of electrons. As I already told, these bonded pair electrons are responsible for both the atoms. E atoms is responsible today, followed by this atom also. Okay, here now count the number of electrons: 2, 4, 6, 8. Next 2, 4, 6 and 8. Okay, this is an example for double covalent bond that each oxygen atom possesses 8 electrons. That means they attain the stable electronic configuration. Here, how many electron pairs are utilized for the formation of bond? Here we have 2 electron pairs are required. This is one electron pair, this is another electron pair. That is why this is an example for a double covalent bond. Double covalent bond it is. Then which type of covalent bond it belongs to? ಯಾವ type of covalent bond is result ಆಗುತ್ತೆ? Both the atoms are having same electronegativity difference. Both are oxygen atoms, both are having same electronegativity difference. If there is a change in electronegativity difference, that may result of unequal sharing of electrons. But here both the atoms are same, both are having same electronegativity difference. That is why there is no unequal sharing of electrons. Instead, equal sharing of electrons takes place between both the atoms and results in the formation of a non-polar covalent bond. This is non-polar covalent bond. Okay, this is an example for a double covalent bond. Okay. In the next class, we are going to continue with the same chapter with a few more examples. Okay, thank you.